I don't know.
Is he doing math yet? They have math in pre-K?
Kindergarten.
Or kindergarten, yeah.
Some kind of math. He does math when he's at Grant.
Yeah.
All right. All right, so we got a couple of word problems here. We're not going to be afraid of them. We've got our calculators to help us with these big numbers. And, okay, so we have all these, okay. Write a linear equation. So in other words, we're going to write the equation of a line for spending y in terms of x using the first 2 points in the table. So, first of all, please make sure you're reading your question completely. For spending y in terms of x, that means your ordered pairs are like they usually are, y and x. So we're going to have 1998, 5.9, and 1999, 6.3. Right, so we're going to write the equation of the line. So step 1 is going to be find the slope. So 6.3 minus 5.9 over 1. 0.4. Is that right? And then what? I don't know what you're going to do. I'm going to do y minus 5.9 equals 0.4 x minus 1998. Now, I'm doing point slope. You do not have to do point slope. You set this up any way you want. If you like to do y-intercept and find b, that's so fine. This is what I'm going to do. And then I'm going to go ahead and get my y by itself, because that's what the problem says I need to do. This is y in terms of x, which is what the problem said. Did I do, check in my arithmetic with yours, is it okay?
Yep.
You okay with that? All right, so, part B says, use the equation to predict the spending in 2002. How would I do that? Use the equation. How would I do that?
Keep y variable and then plug 2002 into x.
Yep, because it's the year, right? And when I set up my ordered pairs, it was year, what is this, money or something? Yeah. All right, so 0.4 times 2002 minus 7. I got 7.5 trillion. Is that what you got?
Yep.
And according to the table, the actual data value was 7.4. And actually that difference between the predicted amount and the actual amount is kind of a big AP pre-calculus topic. We're going to spend a lot of time with it. It's called the residual, and we'll learn how to calculate those and find them on our calculator and all that stuff. But yeah, that takes care of that.
Wait, Mrs. Ford, how did you get 7.5 trillion?
I have absolutely no idea. I typed it on my calculator, but I could have done it wrong. I did this right here. And when I typed that in, I got 7.5.
Oh, and then you just added the trillion? Oh, I thought you
Well,
got...
did you read the question there?
It's trillions.
The y values are in trillions.
Ah, I didn't see that.
He saw 7.5.
Alright? Now, I'm gonna hold up on C for a second. I would like you to take a look at number 12. And with your partner, I want you to see if you can answer problem number 12. All the parts of number 12. Now, in case you forgot, this problem is talking about simple interest. Do you remember how to calculate simple interest? Your simple interest formula is I equals PRT, where I stands for interest, P is your principal, or your investment, R is the interest rate, and T is the time. So this is not, I know last year you guys did some complicated interest problems where you used a formula like this. Remember that? That's compound interest.
Oh, yeah.
That isn't what's happening here. We're doing simple interest. So that is the formula. So take a second and figure that out.
What's the difference?
We'll talk about that in a minute. Use this formula to figure it out.
So I is the new amount. P, 18 days. What's R? R is the percent. We have to do it 2 separate times. One for 5%.
That's what the heat.
I think you add percent.
We all gonna be the one.
The rest is in a growth account.
Take off.
I don't even know what's happening.
And then you does it one just think
The amount of interest, or does it one the total amount of money?
Imagine.
We'll see. I'll show you this one.
The principal is part of the money.
Don't think.
Wait, 0.05.
Plus 1800. These easier. Yeah.
I'll look into it.
we could probably do it. I think.
Part A is just how much cash you get.
us all 18,000.
It's the best feeling in the world.
You also put 500. That's well.
But dude,
Well, she's also gonna.
it's so hard to say no.
I'm almost okay.
So we have to go treat like square. So it was team B and team
So we could do charge X is less than
No, we can.
Yeah. And cause we have
It makes sense.
film in the morning.
All right, have you had any kind of
I mean, all week you got
success with this project?
Yeah, we just started throwing them out.
Not really, not good, okay. Let's talk about A. We gotta do A first. What are the possible values of X? Now, do you understand what's happening? She's got $18,000. She's gonna put it into two pots. According to the problem, she has X, this is the 5% pot right here, and she puts X in there. And then this is the other pot over here. What are the possible values of X? Alex?
Like anything between 1 cent and 1,000 or $17,999.99.
Your,
Because it says put some. It says putting part of the money into savings and the rest into the other sales.
I see what you're saying. Would it be possible for her to put all 18,000 in here? Yeah, she said, this is how I'm dividing it up. 18,000 in this pile and none in this pile. Or could she put none in this pile and all 18,000 over here? So you are right there. You have exactly the right idea. This is called our domain. These are the possible X values, and it's everything from 0 to 18,000. That is our domain. Everything from 0 to 18,000. Now, were you able to write an equation that describes the linear relationship? I'm going to leave this here because we're going to come back to it in a minute. But were you able to write an equation for this? What'd you come up with?
I equals 1.05x.
I equals what?
1.05x.
Done?
That's what we have to receive at 25.
Okay, now I want to talk about this for a second, okay? What's X? X is the principal, right? That's how much I put in there. What was your rate?
5%.
5%. Now remember, this formula is finding the interest, not the value of the account. It's finding just the interest. So I don't really want to multiply it by 1.05, do I? Don't I just want to multiply it by 0.05? Now, again, you gotta read, you gotta keep that straight. I want just the interest, and the interest is just the 5%. If I wanted the value of the account, then I would do 1.05, because then I would be including the principal with the 5%. Okay? And time is 1, right? Didn't they say 1 year? So that's good right there. Now, what about, that's just this interest. What's this gonna be over here? How much money is in this box?
18,000 minus X.
Yep, 18,000 minus X. This box gets whatever he didn't get. Okay, so I'm gonna take 18,000 minus X, that's my principal, and what am I gonna multiply it by? 0.08. So my equation, when I clean it up, I'm gonna have to distribute there. I got 1440 when I did it a minute ago. How does that sound? Is that about right? So negative 0.03x plus 1440. that a linear equation? Problem said, right, a linear equation, is that linear? Absolutely. Y equals mx plus d. That is a linear equation. Is everybody okay to this point? You follow all that stuff? Okay, last question says, how much did she invest in each account if the total interest earned is $10.50? What am I gonna do? Plug in $10.50? And solve that equation. I did that. Tell me what you get. I got one. I got it here. So what did you get? 13,000. What'd you get?
13,000.
Yeah. I got just 13,000
Yeah,
here.
Sam, I just got 30,000.
For X worked out to be 13,000.
Yeah.
And then that would mean
But I'm,
this guy was 5,000. Did we follow all that? We good? Everybody okay? All right. So now I want to back up. I wanted to get through that. So P4 is going to be due on Tuesday. We're going to start P5 in a minute, but I want to do a little bit more calculator work and introduce you maybe to some stuff that you haven't done before in the calculator. So we're going to actually come back and do 11C. So in problem 11, which was the trillions of dollars problem, we came up with an equation. Right, remember when we did that? We got this equation, okay? Now, 11C says, superimpose that equation on the scatter plot of the data. So if you were given a table of data, a bunch of ordered pairs, and if we plot all those ordered pairs, that will be our scatter plot. And then we want to see how close our model, this is called our model, this is the actual data, this is the model we came up with. And one thing we didn't talk about is when we wrote this, look back at problem 11, when we wrote this, they told me to write an equation using the first two data points, right? What do you think would have happened if I would have used the second and fourth data points? I would have gotten a different equation. Does that make sense to you? So part of the fun of statistics is figuring out which of those equations would be the best, right? But I need you to understand, you're gonna get a different answer depending on which ordered pairs you pick. Because these ordered pairs, we're gonna see in a minute, do not all lie in a perfectly straight line. They're scattered about. And we found a line that kind of goes through the middle of them. Okay? So now we're gonna look at this on our calculator. So, first thing I want you to do is I want you to find your stat button. My fingers are pointing to it. Did I see it? On the left it says stat. Alright, when you press it, it gives you options. And we're going to choose edit, the very top one, because edit is what we use when we put data into the calculator. So if you are going to put in points, put information into the calculator, you do it in edit mode. Now, do you have two columns? L1, well, you have more than that, but you have an L1 and L2 column. All right, does anybody have anything in those columns right now? Okay, if you have something in the column, I need you to arrow up to the column name, so L2 or L1. So arrow up, so that's highlighted now. Press clear and enter, and it will clear out that column. Okay, then what if you have another one, you highlight the column name, L2, L1. Press clear and enter. All right, now is everybody empty? Your L1s are going to be your X's. So you're gonna type in L1, 1998, 1999, and so on. All the way down your L1 column. One, two, three, four, five, six. All right. Then guess what you're gonna do?
The L2.
You're gonna put in your Y values in L2. So 5.9.
We got a V12 7.9 18 cylinder.
Okay, did you get those in?
V8 5.0.
Got them in?
5.0.
All right, so just hit second quit, second quit. That's how you get back to your home screen.
Oh, I crashed it.
Now, you are gonna ask your calculator, guys, to plot those points. You're gonna ask it to plot those points. Obviously, you have to have your window set to accommodate those points. So I'm gonna go to window, and I'm going to let my X min be maybe 1990. And my X max might be 2010. Those don't really matter exactly. You want to be on either side of your smallest X and your biggest X. Okay, then our Y's. I probably want my Y min to be maybe, I don't know, 4. And my Y max to be maybe 9. Does that make sense? Just so I'm on either side. Okay, now we have to tell it, so go ahead and second quit, go back to home screen. Now we have to tell it to plot these points. So, if you see right here where your Y equals button is, right above it, it says stat plot. So we're going to second Y equals, so stat plot. Everybody with me? And does your plot 1 say, have an L1 and an L2 by it? That's perfect, because what do we want it to plot? We want it to plot the numbers in L1 and the numbers in L2, okay? So, go to, or press enter on plot 1 there, or yeah, press enter, and now you need to turn it on. So highlight the on. And I think we've done enough. Press graph and see what happens. If you press graph, you get some points. On my calculator, it's enough. Okay, you didn't set your window.
Oh, yeah. So what?
Yeah. You want that to be positive. You actually, you want it to be positive down.
Nope. Go back to that. Alright, stop working.
1990.
Yes,
And then.
and then you want Y to be 4.
I didn't do anything.
One minimum.
No, it's just not like question talking right after the question.
But
You've gotten some points,
We're still at the windows.
right?
I'm gonna help you with this.
Okay, you're gonna have to wait a second. All right, so you got your points on there? They're not perfect, but they're sort of straight, yeah. Now I want you to go to Y equals and type in our equation of our line we built. So go to Y equals, type that in, and press graph. And now you will see the line on top of your points. Our line's a pretty good line, isn't it?
That's excellent.
Yep. So let's review those steps. If we want to plot points, right? Plot points. We have to put the points into our lists using our stat menu. And then we have to tell our calculator to turn the plot on, stat plot. I want you to plot when I put it into my stat menu. Okay. The single biggest mistake that's made when kids try to do this is they don't adjust the window. The window has to fit the data points. Okay? So if you're doing negative 10 to 10, it ain't gonna work in almost every problem because your data points aren't usually negative 10 to 10. So make sure you adjust your window. All right. All right, on we go to, P5.
I love technology.
All right, zero product property. Anybody know what the zero product property says? You use it all the time. Maybe you've never given it a name, but trust me, you use it all the time. Alex?
Something times 0 equals 0.
No, but that's a great guess. That is a great guess. The zero product property, if I gave you an equation like this, and said solve it, I hope that you would all do this. What's the next step? Set an each equal to 0. Now you do that in your head, but that is what you're doing, right? That's the zero product property. If A times B equals 0, then what? Either A is 0, B is 0, or both, right? The only way you can multiply two things and get 0 is if at least one of them is 0. That's the zero product property. What is a quadratic equation? We got one right here. What's a quadratic equation?
Something that the degree is 2.
Exactly. So it's ax squared plus bx plus c. And a cannot be 0. What happens if a is 0? It's not quadratic anymore, it's linear. So this is an example of a quadratic equation. Quadratic formula. If you want to solve, I solved this one by factoring, but you know, not everything factors, right? Remember your Algebra 1 teacher would give you problems, tell you to factor, and you spent hours on it, and it didn't even factor? What do we do if they don't factor? Well, we have to have another method, and that's the quadratic formula. Anybody remember it?
B plus or minus square root of B squared
4AC
all over 2A.
Okay, that was kind of all jumbled up. I hope you all said the right thing. I wrote the right thing.
Yeah.
That is another reason, by the way, guys, that A can't be 0. What would happen if A were 0?
It'd be
A undefined. A cannot be 0, right? You're gonna do quadratic. Perfect. Perfect, perfect. Now, I left all that space in there because we can actually derive the quadratic formula, but I don't think we're going to. I don't think we're going to derive it. I think what we're going to do is talk about the nature of the solutions. And this hinges on the discriminant. Does anybody know what we mean when we say discriminant? Yep.
Doesn't it have to do with what's under the radical to straight how answers?
It's exactly what it is. It's what's under the radical. So the discriminant is b squared minus 4ac. It is not the radical. It's just the b squared minus 4ac. So I want you to think about this for a minute. If b squared minus 4ac is negative, it certainly could be. You could solve it, and it could be negative. If b squared minus 4ac is negative, what kind of answers are you going to end up with? Imaginary. They're going to be imaginary, aren't they? They're going to have eyes in them. So we're going to get two imaginary roots. And the reason we're going to get two is because that guy right there. So if this all came out to be -4 and you took the square root and got 2i, you're going to have something plus or minus 2i over something. So you're going to get two answers. What happens if the discriminant, do it all and it actually equals 0? What's going to happen if you get 0 under there? You're going to get, actually, you're going to get 2, but they're going to be the same. So effectively, you're going to get 1 root, because it's going to be plus 0 and minus 0. Now tell me about that root you get. Will it be imaginary? No. Will it be real then? Yeah. Will it be rational or irrational? Rational. Because if this is 0, the radical's gone. And you're going to have negative b over 2a. So you're going to get 1 rational root. Now, what if b squared minus 4ac is positive? Now, there are two things that can happen if it's positive. If it's a perfect square, so in other words, if you do your discriminant and you get 16, tell me about your answers.
Before?
If that's 16, you'll have plus or minus 4.
Plus one, yeah.
So there'll be 2 of them, and they will be rational. You're going to get 2 rational. If it's not a square, you're still going to get 2 of them, but if this is something like 17, they're going to be plus or minus the square root of 17. So you're going to have 2 irrational. Does that make sense to you? So now what we're going to do is we're going to solve with zeros, we're going to solve with intersections, we're going to solve by factoring, we're going to solve by rooting, we're going to solve by completing the square, and we're going to solve with the quadratic formula. So we're going to solve some quadratics in about a zillion different ways. Okay, so here we go. Go back to the calculator. We're going to solve graphically. Now, I know what some of you are thinking. I don't want to do this graphically. I don't care. We have to do it graphically. We have to practice. Okay? What's the very first thing you're thinking about? You got to change that window. So I'm going to go to zoom 6. Remember, if I zoom 6, it gives me a standard window. You can adjust it however you want, but I always start with a standard window and see where I go from there. What else do I need to do?
Turn off the clock.
Probably a good idea to turn it off. Some of your calculators, it isn't going to matter. On some of them it is. So turn off the plot.
How do you do it?
And how do you turn it off? Go back to that plot again. So second y equals that plot.
Second Y.
Hit enter, and then highlight off.
Can you
You also, in the heading, when you turn on stat plot, when you do second stat, across the heading, You have plot 1, plot 2, plot 3. Unhighlight them all. Unhighlight stuff. You can also do it that way. All right, now what? Our plots are off. Our window is reset. Now what do I do? Type in my equation. So 2x squared minus 3x minus 2. And hit graph. And what do we need to see? We know we're on target if we see what? Where it crosses the x-axis. Because that's what we're doing. We're finding out where it's equal to 0. Where does it cross the x-axis? So, does everybody see it crossing the x-axis? Let's find them. How do we find those points? Second calc 0. But I'm finding this point right here. So I'm going to set my left bound over here, my right bound over here, and put my cursor in between there, and that point is indeed negative 1/2 or negative 1/5. Fred's nodding. Fred's on target. Anybody else on target?
Yeah.
All right. So we're going to find that one. So second calc all over again, 0. Move that cursor. Now I need the left bound to be here. And the right bound to be here. All right, press the wrong button. And for that one, did you get 2?
Second, trace what?
Now, I need you to always pay attention to the problem. This is an equals. So the answers are x equals negative 1/2 and 2. Yesterday or one other day when we did this was like a less than. Everything's exactly the same, but your answer now to that problem would be this. Would you agree with me? So if that had been the problem, then my answer would be the interval from negative 1/2 to 2. When it's an equals, like it is, it's just x equals. If it's an inequality, it's a shade. It's shaded somewhere, right or interval. Okay? So, Gus, why was your hand up?
I think so.
You figured it out? You're amazing. Good job. All right, would you try D? Try D with your partner. It's exactly the same thing, but it's not a quadratic. It's not a quadratic.
Yeah, really. If it's squared, it's flat.
Is that like consistent?
The squiggly.
Yeah, if it's cute, it always looks like yeah.
What?
No,
No, squiggly.
There's a name for it.
Squiggly.
Squigglies, that's what I call them.
Squiggly.
Cubes are squigglies.
No idea.
Always squigglies. Now, it's possible for a cube to squiggle like this. So in that case, you would be looking for more answers. But your squiggle doesn't squiggle all the way through the x-axis. So I only have one. And tell me what you got.
1.3.
Remember, we're going to the thousandth always. Let's get in that habit. If we're rounding, it's at least 1,000. So 1.325. tell me what the answer would be to this problem.
Anything above that.
Anything above that, so we would say 1.325, comma, infinity, right? Pay attention whether it's an equation or an inequality. All right, now we're gonna do intersections. That's a cube. So we're practicing different strategies on our calculator. So do you remember what you do here? What am I gonna do? Type in both equations, right? If I'm using intersections, I'm gonna type in both. So I'm gonna type in 3x cubed, and to get x cubed, you can use that button right there, that arrow button, that'll give you x cubed, and then 12x. Now, I left my window the way it was. I left it as a standard window, and I am seeing something like that. Does that kind of match what you're seeing? Okay, now what are we looking for? Points of intersection. I clearly see a point of intersection. Looks like the origin. I can check that to be sure. It sure looks like the origin. But I'm a little bit concerned about what I'm seeing here. Is it possible, do you think, that there is another point of intersection up here? And another one down here? How could I see that better? Change my window. So what do you suggest?
Lower the x, raise the y.
Lower the x, raise the y. So what Cole is saying is, we really don't need to see this much of the picture. So he says lower the x, so maybe go with -5 to 5. But I need to see more height, so maybe -30 to 30. So that's a pretty good guess. Now do you see those points of intersection? All right, let's find them. You're gonna have 3 answers this time. There's 3 points of intersection. Use your intersect calc, second calc intersect. You got? I got 0, 2, and -2. Remember, I'm solving for x. So when I found my points, I got y's, but I don't really need the y's. I need my x's. Okay, here's a challenge for you before I erase all this. What if the problem said this? Now that means the squiggle has to be above the line. So my picture's not very good, but that would happen right here. And right here.
So then is it just the line, or is it? Yeah, we wouldn't be shading.
Well, I'm shading the line. I'm coloring the line. So what is the pink X's? What are the pink X's? Starting at -2 and going to 0. And then picking up again at +2 and going to infinity. Alright, we're gonna redo the same two problems that we just did, but we're gonna solve them by factoring. And we better get exactly the same answers. So we're gonna factor this guy. Does he factor? Hopefully. Come on, shake out those algebra 1 cobwebs. Guys, we gotta factor. That would be -2 + 1. So using that zero product property, what are my answers? X equals
2,
-1/2 and 2. Is that what we got before? Of course it is. Those are the answers. What are you gonna do with this guy? We're gonna solve by factoring, so what's the first thing I have to do? Get it set equal to 0. You can't use the zero product property if you're not equal to 0, so you gotta get it equal to 0. How does that factor? You got an X and a 3. And that will leave me with X squared -4, which makes me really happy because that's called the difference of squares, and it factors into
X minus 2.
-2 and +2. So what are our answers? X equals 0, 2, and -2. Exactly what you have. 4x squared equals 25. Solve by extracting square roots. That is the math way of saying, take the square root of both sides. So what do we got here? Square root of 4x squared is 2x. Square root of 25 is plus or minus 5. Guys, you gotta get 2 answers, okay? You gotta get 2. Anytime you take the square root of both sides of the equation, one side has to be plus or minus. Okay? Technically, they both are, but if you do both, you're gonna cancel out half of it anyhow. So one side has to be plus or minus. So our answers are plus or minus 5/2. All right, one more problem. Got one completing the square. Do you remember anything about completing a square? I think you do because we talked about it with circles. This problem doesn't factor, so I wouldn't be able to factor it. So I'm going to solve it by completing the square. What is the first step? Move the 4 over. And when you move the 4, leave the gap, because you are going to find a new number to put in here, right? That's the completing the square part. What's that number going to be? 25. And how did you get 25?
10 by 2 and then square.
Half of 10 squared. Half of 10 squared. Divide by 2 and square. What did you do that for? Why? What was the point? So you can make this a perfect square? What perfect square is that? That's plus 5 plus 5 equal to 29. Now can I do that little trick right there? Now can I do this? I sure can. What's the square root of x plus 5 squared.
X plus 5.
X plus 5. And this is plus 4 minus 29. And I'll move my 5 over. And there are the answers. We'll do B next time, but it's gonna be a bit more of a challenge. What's wrong with it?